Okay, extraction of iron. So from the ore hematite in the blast furnace, and describe the reaction involved. So first, what will happen? We have a coke. So we have a coke. So what will happen? The coke will react with oxygen. When the coke will react with oxygen, what it will form? It will form. Yes.
Very good. Like there we can see everything.
Coke will react with oxygen to form a carbon dioxide. And this formation of a carbon dioxide, it makes the reaction exothermic. In exothermic reaction, because for extraction we need the furnace temperature to be very high. That's why we want this first reaction to be highly exothermic. So the equation for this reaction, carbon reacted with oxygen to give off carbon dioxide. That's the first thing. Then carbon dioxide reacted with more coke. So the carbon dioxide reacted with more coke to produce carbon monoxide. How do we know that this is the first reaction? Why we call this as a first reaction? Because this is the only reaction which is exothermic. So, and the furnace temperature, when we start the beginning of the experiment, the furnace temperature was at same as, like example, room temperature. But when we blow a hot air and add a coke from the top, we find that the furnace temperature rises to 1900 degrees centigrade. So this give an indication that this is the first reaction. So carbon react with oxygen to give off carbon dioxide in an exothermic reaction. Then what will happen? Yes.
This way the graphs too.
You have to ignore this point. Wrong point we ignore. Draw a
So it
straight.
should be straight.
Yeah.
Should I ignore it? Continue or just?
Yeah, ignore that and continue. So then what will happen? The carbon dioxide react with coke to produce carbon monoxide.
Why not another thing or anything between the?
No, only coke. Because it contains carbon. So carbon dioxide react with the coke to produce a carbon monoxide, which is a reducing agent. Yeah, keep it here.
The earphone so. Everyone there?
So yeah, because it's a 1 hour. So this is a reducing agent when a carbon dioxide. So the reaction here, a carbon dioxide reacted with more carbon to produce a carbon monoxide. Then what will happen? Because of a space, I will write it here that this carbon monoxide react with the ore of the iron. It react with the iron ore and reduce it. So what is the reaction for this one? The ore of the iron, which is the hematite, iron 3 oxide, and reacted with the carbon monoxide. So carbon monoxide is a reducing agent. When we say a substance is a reducing agent, means it has a tendency to remove oxygen. It has a tendency to remove oxygen, so oxygen will be removed from this. So it will form iron and produce carbon dioxide. But the equation must be balanced. So this is a balance equation for a reduction of ore of the iron. Then this iron ore also contain an impurity. So that is a acidic impurity. Silicon 4 oxide, which is neutralized by calcium oxide. And how calcium oxide is produced? The calcium oxide is produced by decomposition of thermal decomposition, or you can say decomposition of the limestone. And we have to write that equation as well for the formation of a slag. So actually this happened first, that the calcium carbonate, because of the heat energy, decompose into calcium oxide and carbon dioxide. And that calcium oxide, which is a basic oxide, react with a silicon 4 oxide, acidic oxide to form CaSiO3, which we also call slag. Lime is different. Limestone, you have to say, because lime is calcium oxide, is called lime. So you cannot say decomposition of a lime. You should say decomposition of a limestone. So this is a complete reaction for a thermal in which we extract the iron from the ore. But this iron is not a pure iron. Still, it contains carbon as an impurity. The soluble salts, yeah, that's right, the name, the pig iron. The soluble salts can be made using a base and acid. If we mix a base with an acid, we can prepare the soluble salts. Complete this method of preparing a dry crystals of a soluble salt for a cobalt 2 chloride dot 6 like 6 water molecule from insoluble base cobalt carbonate. So first add an excess of a cobalt carbonate. So first when we add an excess of a cobalt 2 carbonate to hydrochloric acid. So first we'll take a beaker and we have a hydrochloric acid in a beaker, HCl. But in this HCl, we add an excess of a cobalt carbonate. So when I add excess of a cobalt carbonate, so cobalt carbonate is more than enough. This will be the unreacted cobalt carbonate or a cobalt 2 carbonate, the unreacted one. And what will happen to HCl, because we use a limiting HCl, excess of a cobalt carbonate. So this HCl will now turn into a cobalt chloride solution. So first we have to remove the unreacted cobalt chloride. So first we filter off the excess of a unreacted or cobalt chloride, which will be there in the residue. So we use a filtration here in the first method. So when we carry out the filtration on the filter paper, what is left? The left is a cobalt carbonate, unreacted. And what passes through the filter paper, that is a filtrate, that is a cobalt chloride solution, aqueous cobalt chloride. Then how we carry out the, because it's a soluble salt, so soluble salt we have to use crystallization. So what should be the step 3? We will heat and concentrate the solution till the point of crystallization and then cool down. So we heat and concentrate the solution until the crystallization point is reached. And once we reach the crystallization point, we will cool down this. Then what we have to do, we have to just filter it off. Filter to remove hydrated cobalt chloride salt. But we can, and we can filter it off and then we can dry with a tissue paper, but we cannot use an oven here. Why we cannot use an oven for drying? Because this is a hydrated salt. Hydrated salt. Arham, turn around. So hydrated salts are there. These hydrated salts. These hydrated salts cannot be heated in oven. So that's why we have to dry with the tissue paper. So first what we did, we add more, we have a hydrochloric acid, the HCl is there. In this HCl, we add excess of a cobalt carbonate. When we add too much cobalt carbonate, there will be unreacted cobalt carbonate and the solution will turn into a cobalt chloride. This will be a cobalt carbonate which does not react. First thing we have to remove this. How to remove? So we have to carry out a filtration. When we carry out a filtration, the cobalt carbonate, which does not react, will be left on the filter paper and the cobalt chloride will be there as a filtrate. Then we use this filtrate and we use heat concentrate till the point of crystallization and cool until the crystals will start to appear. And then we will filter to remove that crystals of our cobalt chloride and we can dry with a tissue paper. So these are the points you have to mention about this. Hmm? Points of crystallization, but right in step, like, because it's, yeah, step 3 and step 4 are there. So step 3, you make a crystal. How you make a crystal? Heat the solution till the point of crystallization and then you cool it down. And then step 4 is you remove the crystals by not wash. You cannot say wash, because if you wash this crystal, then it will dissolve again. That's why for soluble crystal, you cannot say wash. You will always say dry. But and even here, you cannot say dry with a in oven, because if you try to dry, it's a hydrated salt. So hydrated salt will lose its water crystallization if you supply heat energy. So you cannot heat them.
Say in step 2, can we only write filter the solution? Will that be correct? Like filter the solution.
Yeah, we did that
Step two.
filter.
No,
Why we need-
that if we only write filter the solution, will that then
Yeah, it's
come
okay.
up? Okay.
Why we need excess of a cobalt carbonate here? To make sure all hydrochloric acid reacted. We are not adding cobalt chloride, we are adding cobalt carbonate. So when we add a cobalt carbonate, COCO3 to a hydrochloric acid, so this reaction will happen or occur, and the solution will turn into a cobalt chloride, and hydrochloric acid will be used up, and some of the cobalt carbonate which does not react because we use an excess. So that is the excess one is removed by filtration. So it is always the point, whenever you prepare a salt by metal oxide or a metal carbonate, you always use excess of them so that you can remove the excess by filtration.
Sir, I can write
The next one, it's related to the moles concept. So first one, 5.95 grams of a cobalt 2 carbonate were added to 40 cm cube of a hydrochloric acid of concentration 2 mole per dm cube.
40 divided by 1000.
So calculate the number of moles of HCl. So this is a volume of HCl and this is a concentration of HCl. How to get the moles?
Concentration multiply by volume, we divide 40 by 1000 and then we multiply it by 2. Yeah. I think 0.04.
नीचे वाला सॉल्व कर एक्सेस
Okay.
तो बोलते हैं कि कोई भी सवाल होना नहीं चाहिए.
So number of moles of HCl, moles is concentration times the volume. What is the concentration? It is 2. And what about the volume? It is cm cube, 40 cm cube. How to convert into dm cube? Divide by 1000. So 40, how much? No, the final answer. 0.08. 0.08 moles of HCl. Then number of number of moles of cobalt chloride form. So how to know? You have HCl and you need cobalt chloride, so you will take a ratio. What is the ratio between them? 2:1. If 2 HCl moles are there, it will give 1 cobalt chloride. So if you have 0.08 moles of HCl, how much cobalt chloride? It will be X, cross multiply, so you will get 0.04. Number of moles of cobalt chloride, 6H2O. So now from cobalt chloride to hydrated cobalt chloride, what is the ratio between them? 1:1. So if the ratio is 1:1, so you'll get the same answer. Because if I have a cobalt chloride and I need hydrated cobalt chloride, according to a question, it's the ratio 1 cobalt chloride give 1 hydrated cobalt chloride. So ratio is 1:1. If we have 0.04, so this ratio was giving us 0.04. Then we have a cobalt chloride 0.04. How much hydrated will be there? X cross multiply So how many moles we'll get? We'll again get 0.04 moles. The mass of 1 mole of hydrated cobalt chloride is 238. Maximum yield means like maximum mass. So how to get the mass in gram? So we have the formula moles equal mass in gram divided by molar mass. The moles of the cobalt chloride were 0.04. The mass in gram is unknown. The yield or the mass in maximum yield or the mass is unknown. And what about the molar mass? Molar mass is 238. So 238 is divided, other side multiplied. So how much we will get? We'll get 9.52 grams. Okay. That's how, so for how we did this question, the first to get the moles of HCl, we use a concentration times the volume. To get the moles of cobalt chloride, we use the ratio between hydrochloric acid and a cobalt chloride. 2:1. Then to get the moles of a hydrated cobalt chloride, we again use a ratio which is also 1:1. And then to get the mass, we just multiply moles with a molar mass. We got the mass in gram.
Kilogram or gram?
Mass in gram. Always mass will be in gram.
Okay.
The next is to show cobalt carbonate is in excess. First, the moles of HCl used. So how many moles of HCl we use? We use 0.08. That is already, if you see this answer, this is the answer. You use your value from above.
सर चेक करेंगे तो नहीं मेरा एक पेपर मिसप्रिंट हो गया है, मुझे
Mass of 1 moles of cobalt carbonate is 119. Number of moles in 9.59 gram. Yes. So number of moles of cobalt carbonate used. So how to know the number of moles of cobalt carbonate?
ratio.
No,
Uh,
we have in, because we have the mass, number of moles of cobalt carbonate in 5.95. So what, how to get the moles? Mass in gram, 5.95 divided by molar mass. Molar mass of cobalt carbonate is 119. So 5.95 divided by 119, we got 0.05. So according to equation, the ratio between cobalt carbonate and HCl is 1:2. Like if we have a cobalt carbonate and we have HCl, according to equation, the ratio should be 1:2. But according to the moles which we have, how many moles we have for cobalt carbonate? 0.05. This is Mach 4, set 4. And how many moles of HCl are there? How many moles of HCl are there? So 0.08. If I take a simplest ratio between them, I'll divide by the smallest value, 0.05, 0.05. So what will the simplest ratio between them? The simplest ratio between them, 1:1.6. So according to the simplest ratio, according to the moles which we have, HCl is not excess. Look, according to the mole ratio, when we worked out the mole ratio between them, our mole ratio is 1:1.6 for a cobalt carbonate and HCl, according to the amount which is given to us.
maximum yield क्या लिखते हैं आपने?
Mass in gram, maximum yield or a mass in gram.
मैंने
तो हमारे पास सिर्फ एक ही ऑप्शन है सी
तेरे एटीपी में एंगल्स का होता है इसमें
So what?
एटीपी में एंगल्स का होता है
Yes. Yeah, so if you compare the moles, you can compare the mole ratio or you can take a simplest ratio between them. According to the moles which you have, the ratio is 1:1.6, but according to the equation, the ratio is 1:2. So it means HCl, because for a complete reaction, you should have 2 moles of HCl, but you don't have 2 moles, you have only 1.6 moles of HCl. According to the ratio, if 1:1.6, it means HCl is a limiting. You don't have enough HCl. So I'll repeat like how we got this. The first part, we need the number of moles of HCl. So we were having a volume and a concentration. So we multiply them. The volume was 0.04 and the concentration is 2. So we got 0.08 moles. How to get the moles of a cobalt chloride? Let them at least. Number of moles. Huh? How to get the moles of a cobalt chloride? So we took a ratio between the HCl and the cobalt chloride. According to the equation, the ratio is 2:1. So if we were having 0.08, so we took a mole ratio, we got 0.04. How to get the moles of cobalt, hydrated cobalt chloride? The ratio between anhydrous and hydrated is also 1:1. So if 1:1 is a ratio, again we'll get 0.04 moles. Then how to get the maximum yield or a mass in gram? We have the molar mass and we have the moles, we just multiply them. So if we need the mass in gram, moles equal mass in gram divided by the molar mass. So moles were 0.04, mass is unknown, and molar mass is given 238. So when this was multiplied, we got 9.52 grams of hydrated cobalt chloride. And then when we work out the moles of HCl were 0.08 and moles of cobalt chloride were 0.05. So when we were taking a ratio between a cobalt carbonate and HCl, according to the simplest ratio, like this moles are 0.05 and this moles are 0.08. When I take a simplest ratio, I'll divide by the smallest value. So this will be 1 and this will be 1.6. So we have a ratio of 1:1.6. But according to equation, the ratio should be 1:2. So we don't have 2 HCl, we have only 1.6 HCl. It means HCl is a limiting reagent. So whenever you want to find a limiting factor or reagent, you always compare the mole ratio. So how this calculation shows that the cobalt carbonate is in excess? So you will say because the mole ratio. Arham. 0.04 moles were needed for a reacting, or yes, you can also write that as well.
So that क्या बताया तो सही आगे
This.
That.
You can write either a mole ratio that for a complete reaction, the mole ratio is 1:2, but we have the ratio 1:1.6. So
आप रेशियो भी लिख सकते हो डेफिनेशन में
yeah, you can also say like for a complete reaction, how many moles you need. Iodine react with the chlorine to form a dark brown iodine monochloride. This react with a more chlorine to give a yellow iodine trichloride. So what do you understand by the term equilibrium? Equilibrium means when the rate of forward equals to rate of backward and there is no change in the concentration of keeping the concentration of the reactant product same. That's right. But don't say reactant and product have the same concentration. That will be wrong. If you say
no change in concentration.
Yeah, that's right. When equilibrium mixture is heated, it becomes dark brown. So it becomes dark brown. If we heat, it means the equilibrium has shifted towards the left hand side. So what is the forward reaction? If we heat, we got a backward. For exo, when a forward reaction suggests if the reverse reaction is endo or exo. Reverse they are asking.
Yeah.
So reverse is endo because reverse reaction, when we increase the temperature, we got more dark brown. And if they ask what about the forward reaction? Yeah, if you don't receive, just let me know. So yeah, all sets are marked. I shared last week.
अरे कौन चेक करता है फिजिकल सर करते हैं ऑनलाइन और फिर आप वो क्यों नहीं चेक करते
How I will check that as well. If it's not,
मुझे आप फिजिकल चेक कर सकते हो वो वाले भी मॉक्स चेक करना
कौन से
हमारे की मार्किंग बड़ी बुरी है इन बच्चों की
आपने फ्री में मेरे मार्क्स एफिशिएंसी में इनपुट के बजाय क्या
the pressure on the equilibrium mixture is decreased. How would it affect the position of equilibrium? If I read, you always check the moles of the gas. Here we have a liquid and here we have 1 mole of a gas, and here we have a solid, so 0. So whenever we increase the pressure, if we increase the pressure, equilibrium will shift towards side of a less moles of the gas. And if we decrease the pressure, equilibrium will shift towards the side of the more moles of the gas. So in this case, what we did, one is a liquid, like in the reactant side, one is a liquid, in a product side, one is a solid. So only one gas is there. And what we did, the pressure and equilibrium mixture decreases. So when I decrease the pressure, equilibrium will shift towards side of more moles. So where I have more moles of the gas?
The left side.
The left hand side. So it means, now in the question, it will not shift on the right hand side. Why? Because if you read the question, the increase in pressure shift the equilibrium towards side of a less moles, and decrease in pressure shift the equilibrium towards side of more moles. But that is the moles of the gas. So in this question, when we compare the equilibrium, we have to see the states. So you don't only see the amount, see the state. When you see, this is a liquid, so there is no effect on the liquid. This is a solid, no effect. So this is only a gas, so 1 mole of a gas and 0 moles. So when I decrease the pressure, equilibrium will shift towards side of a more moles, so it will shift towards the left hand side. So what I have to say here, so how would it affect the position? It will move towards the left hand side and a backward, and reason is that because there are more moles of.
So last question.
Okay. Why? Planning.
First time to see it.
No, try to take your time. Then describe what would you be describe what you would observe. So if the equilibrium shift toward the left hand side, what we will observe? So it will become dark brown. On the it is shifted towards the left hand side. So if equilibrium shift towards the left hand side, so it will become darker. Where the equilibrium, look, you have to understand the position of equilibrium. As the equilibrium, where you are shifting the balance. So where the balance is shifting, if you see the balance is shifting towards the left hand side. If we shift towards the left hand side, so it will form a dark brown like liquid.
Sir, can you use round bottom flask for decomposition?
For thermal decomposition, test tube is appropriate.
So why not beaker?
No beaker. If you want to collect the gas, then no, not beaker. No, if you want to collect the gas.
If you want to collect gas,
Then test tube with a delivery tube and
Say if I know until there are no bubbles, is that correct? Until there are no bubbles.
Yeah.
So
enthalpy change. Calculate the overall energy change for a reaction between iodine and a chlorine. So you have the reactant iodine react with chlorine to form iodine chloride. So this is a bond breaking. 151 and 242 is a bond breaking energy. Bond forming energy is 2 times 208. So the reaction negative enthalpy change means that the forward reaction is exothermic. And we have to draw for exothermic reaction energy diagram. In exothermic reactions, reactants have high energy and the product is having low energy. So when we sketch a graph,
after oxygen and before,
reactant will have a high energy, the product will have low energy. The minimum possible energy which we need for a reaction to start, we call activation. And enthalpy change, some student draw arrow like this 2 ways, that is not the right. If it's an exothermic reaction, If it is an exothermic react, it's always from reactant to product, one direction arrow. Exothermic, it will point downward. Endothermic, it will point upward. So iodine reacted with the chlorine to form two molecules of iodine chloride. And the forward reaction is exothermic, which is minus 23 joules. And this is the activation energy.
The Indian Cricket League, sir. I see.
वो हमसे तो बेहतर ही है
The next,
ICL IPL नहीं same general formula IPL है IPL same
yes, you will lose the mark if you draw the double arrows. You will lose the mark. If you in exam for enthalpy level energy diagrams, if you draw the arrows two ways, you will lose the mark. So it's the question is, give three characteristics of the homologous series. Same general formula, same functional group, each member differ by CH2.
सर मुझे पता है कौन से चैप्टर आते हैं सर केमिकल रिएक्शंस
The following two alcohols are the member of the homologous series and they are isomers.
Same structure formula.
So same molecular formula but different structure.
Formula but different
Then reduce the structural formula of another alcohol that is the isomer of these three. So this is OH is attached with the first carbon. This is a branched alkane, like the carbon chain. So what we can do, we can just change the position of OH. OH we can attach with the second carbon. Reduce means work out. Like so. So you just change the position of the OH. OH was attached with the first carbon.
रमजान की मैं टाइमिंग करते हैं
वो भी आएंगे बहुत टाइम नहीं देखना होता है साइकिल कब देगी तो सारी की क्लास के भी रिमाइंडर लगा दो सर क्लास 10 बजे कब होगी क्या
सर मेरी क्लास 2 घंटे पहले खत्म हो
मेरी
गई
बहुत बुरी तरह अच्छी है शायद यार दिखा है अब स्मूथ हो गई
Oh, the next one is copper 2 oxide can oxidize a butane to all whose pH is 4. The mineral wool soaked in a butanol and a copper 2 oxide is there. Oxidized means like it can add oxygen when alcohols are oxidized. What will the liquid X will be formed? Alcohol oxidized to what? Butanoic acid. Yeah, that's good. Alcohols oxidized to, it can be a bacterial oxidation or we can use an oxidizing agent for that. Name another reagent which can oxidize butanol. What oxidizing agent could be used?
Potassium manganate.
Yeah, potassium manganate 7. That's right. Don't forget to write as an acidified is the condition. So it's acidified potassium manganate, and some students are not writing this Roman number. It's very important to write that as well. So acidified. No.
free the marks दिया हुआ है सर
Okay, I will deduct it.
ऐसा जुल्म होता है सर
जरूरी क्यों है नंबर लिखना
Because transition element have different oxidation states. So this Mn7 is actually responsible for this reaction. If you write, this is the main thing. Like if you write, because Mn can be 2, it can be 4, it can be 5, it can be 7. 7 is responsible for this reaction to happen. That's why it is very important to write potassium manganate 7. Question 8, part C. Which homologous series the liquid X belongs to? It belongs to a carboxylic acid. And the formula of liquid X, because this is not right. Why it is not right? This is a pentanoic acid, but a butanol will form a butane. This is also not correct. Because it is a butanol, butanol will form a butanoic acid. So what is the formula of butanoic acid? C3H7COH. Because COH is already, there are 5 carbons. 4 carbon here plus 1 carbon here. 4 carbon I said. No, I'm saying 4 here and 1 here, so it makes 5 carbon. This is a pentanoic acid. I wrote C3H7COH. Yes, it's right.
Sir, C3H8O2 ठीक है H9
C3H.
8O2 4.
No, it should be C4. If you write, then either it should be C4H8O2.
C4H8O2 अच्छा
Because it's a butanoic acid. Butanol oxidized to butanoic acid.
C5
For B2, the diagram was exothermic reaction. For this one, alcohol, we just have to draw an isomer of alcohol. Like 4 carbon atom and OH is attached with the first one. What we simply do, we change the position of OH to the second carbon. That's it. If you want to draw an isomer of alcohol, you just change the position of OH. If it is the first, you just put with the second one. In part D, alcohol, ethanol can be made by fermentation. Yeast is added to a glucose and an equation is given for a conversion of a glucose to alcohol and a carbon dioxide. The carbon dioxide gas is given off and the mixture become warm. The reaction is exothermic. The graph shows how the rate of reaction. So first rate of reaction increase and then it is decreasing. Suggests a method of measuring a rate of reaction because a gas is given off. A gas is given off, so we can measure the volume of a gas in a unit time to measure the rate of the reaction. Why does the rate initially increases? What is the reason for increasing a rate? Because you can see the forward reaction, the reaction is exothermic. So if the temperature increase, actually, instead of writing about yeast here, this part, yeast is already added. So, but still, why the rate of reaction is increasing? Even the reaction will be slower. If you mention about yeast, it's fine. But the main thing, the reaction is exothermic, so the temperature increase. That's why the rate increases. So you should. The main thing is temperature. But why the rate decreases? Because if the temperature is too high, it will denature the enzymes which are present in the yeast. That's why the rate eventually. No, it will not deduct a mark. Like you will not lose as a yeast is active as it's a biological catalyst that is increasing a rate as well. But why the rate? Like example, we use a yeast, it should be started at a certain highest rate. But why the rate is continuously increasing? Because the reaction is exothermic, so the temperature rise. That's why the rate is increasing. So we use a fixed amount of yeast, but the temperature increase causes the rate to increase. And then why the rate decreases? Because a high temperature denature the enzymes which are present in the yeast. That's why the rate of reaction will decrease. So give 2 reasons why eventually rate decreases. One is it denature the enzyme. The high temperature denature the enzyme. The second is the formation of the alcohol, the production of alcohol may kill the yeast because the yeast cannot survive in alcoholic conditions. So one is the enzyme denature in the yeast due to high temperature. Another one is
yeast destroyed by alcohol.
yeast killed by alcohol.
Same thing.
Yeah. Same thing. What? 2 points. That was a. So join from the same link. We'll discuss the question 9 as well. We cannot say the